In this lecture, we are going to discuss about number system conversions. So we are going to cover the conversion of bases like decimal to binary, decimal with the base 10 and binary with the base 2. Then we will convert decimal to hexadecimal, that is base 10 to base 16, and decimal to octal, that is base 10 to base 8. So total we have 12 conversions: decimal to binary, decimal to hexadecimal, decimal to octal, binary to decimal, binary to hexadecimal, binary to octal, hexadecimal to decimal, hexadecimal to binary, hexadecimal to octal, octal to decimal, octal to binary, octal to hexadecimal. So in this lecture we are going to cover the first three conversions. So first conversion is decimal to binary, and here we are going to use the method. The name of the method is repeated division by 2. So what we do in this method, we keep on dividing the given decimal number by 2 and keep on recording the quotient and remainder. Like initially we divide the given decimal number by 2, we record its quotient and remainder. Then again we divide the obtained quotient by 2, and same process that keeps on repeating until we get the final quotient 0. So binary number obtained will be taken from bottom to top, and remainder is considered as the final result, and that is considered from bottom to top. And if we talk about the fractional decimal number, so after the decimal point, how to convert the decimal to binary, that method is called as the repeated multiplication by 2 method. So here we can take one example to understand the conversion, that is decimal to binary. So decimal number we are taking here is 1259.125. So base for this decimal, that is 10, and we convert it to binary with the base 2. So first we take the first part of this number, that is before the decimal point, that is 1259. So we solve this 1259. The method is called as the repeated division by 2 method. And then we solve the second part of number, that is 0.125, and this method is called as the repeated multiplication by 2. So how to solve for 1259? Initially this 1259 is divided by 2. We get the quotient here 629 and remainder here is 1. Then we keep on dividing this with the again 2. We get here quotient 314 and remainder 1. Then again divided by 2, quotient is 157 and remainder is 0. Then again divided by 2, quotient will be 7, 8 and remainder will be 1. Then again divided by 2, it is 39 quotient and remainder is 0. Then again divided by 2, quotient is 19 and the remainder is 1. Then again divided by 2, quotient will be 9 and remainder will be 1. Then again divided by 2, we get the quotient 4 and the remainder as 1. Then again divided by 2, we get the quotient as 2, remainder as 0. Then again divided by 2, quotient will be 1 and remainder will be 0. So when we again divided by 2, quotient here will be 0 and the remainder is 1. So we keep on recording all the remainders starting from bottom to top. Like first we write 1, then this 0, 0, 1, 1, 1, 0, 1, 0, 1, 1. So this is the first part of conversion from decimal to binary. And for the second part, we go for the repeated multiplication by 2 method. Here we multiply this fractional part by 2. We get the result here 0.250. So this 0 we are recording as a result, and then the decimal or fractional part only, that is multiplied by 2. So when we again multiply this by 2, we get it as 0.500. So we record this 0 in the result and we multiply 0.500 by 2 and we get here 1.000. So we record this 1 in the result and we record all the results here from top to bottom. So here we get the result as 0.001. So what is the final result here? This decimal number is having two parts. 1259 is converted to binary. This is the result, and 0.125 is converted to binary. This is the result. So this is the overall result of conversion, that is decimal to binary. And the same way, if we go for the second conversion, that is decimal to hexadecimal, so method here is called as repeated division by 16, as the base of hexadecimal is 16. So this method is called as the repeated division by 16. So here what we do, we divide the given decimal number by 16 and record its quotient and remainder, and then divide the obtained quotient again by 16, and same process we repeat until it produces the final quotient as 0, and we store each remainder in the hexadecimal form, and they are taken from again bottom to top. And for the fractional decimal number, the conversion takes place by repeated multiplication by 16 method. Here we take the example of conversion like 1259.125. This is a decimal number that we need to convert to hexadecimal. So first we take first part, that is 1259. We divide it by 16. Quotient here will be 7, 8 and remainder here will be 11. But this 11 that we need to represent in the hexadecimal form, and in the hexadecimal equivalent of 11 is B. Then we divide this 7, 8 by 16. We get the quotient here 4 and the remainder here 1, 4. 1, 4 is represented in the hexadecimal as E. Then we divide this 4 by 16. So quotient here will be 0 and the remainder here will be 4. So finally we get the result as bottom to top, that is 4EB. So 4EB is the result of this 1259. That is the decimal number before the fractional point, and after the fractional point we have 0.125. so here we use the repeated multiplication by 16 method. So we multiply this by 16, we get the result as 2.000. So we extract the decimal value, decimal, or you can say this is considered to be the hexadecimal value. So the digit that is before the decimal is extracted here, and as this result we are getting is 0, so no further conversion is required. So here we get the result as 0.2. So final result here is, for this case we get 4EB and for this case we get 0.2. So this is our final result. Then the third method, that is the decimal to octal conversion. So here we go for the repeated division by 8 method. Like for the first case, that is decimal to binary, we have used repeated division by 2 because the base of binary is 2. Then for decimal to hexadecimal, we have used the repeated division by 16 method because the base of hexadecimal is 16. And now for the octal conversion, we use the method repeated division by 8 as the base of octal is 8. So here we divide the given decimal number by 8 and record its quotient and remainder, and then again divide the quotient by 8, and same process we repeat until we get the final quotient 0, and we store each and every remainder in the octal form starting from bottom to top. And for the fractional decimal number, that is after the decimal point, we use the method for the conversion, that is the repeated multiplication by 8. So for this case we take the example same, that is 1259.125 decimal value that we need to convert to octal. So here we use the repeated division by 8 method, and here we use the repeated multiplication by 8. So 1259 divided by 8, quotient is 157 and remainder is 3. Now divide 157 by 8, quotient is 19 and remainder is 5. Now divide 19 by 8. Quotient is 2 and remainder is 3. Now divide this 2 by 8. Quotient will be 0 and remainder will be 2. So we record the result as bottom to top 2353. So this is the result here. And for the second part of number, that is after the decimal point, that is the fractional number, we multiply this by 8 and we get it here 1.000. So as 0 is obtained, so no further multiplication is required and we extract the value 1 here. So for the 0.125 we get the result as 0.1, and for this case we get it as 2353. So combine this part and this part. Finally we get 2353.1 with the base 8. So this is the worksheet for practice. We can go for these three conversions, that is decimal to binary. We can check the result, then decimal to octal and decimal to hexadecimal. These are the references I have used. Thank you.